Lesson 5.3, Solving Systems of Equations by Elimination. So you're going to want to maybe pause the video to fill this out, but I will also be giving you some kind of a condensed form of that. So if you want to try to follow along, when we want to solve a system by elimination, we want to, step one, multiply, if necessary, one or both equations by a constant. So at least one pair of like terms has the same or opposite coefficient. Basically, you need to set it up so that something will cancel. Step two, add or subtract the equations to eliminate one of the variables. Step three, solve the resulting equation for the remaining variable. And then step four, substitute the value from step three into one of the original equations and solve. So remember, we're looking for the x and the y. I would also like to add that you would definitely want to check your work. So from the textbook, if you look at this example, you have the first equation, x plus 3y is equal to -2, and then x minus 3y. So you can see this is already set up so that if we were to add, oops, let's try this again. Add these together, right, straight down. That these two right here, because they are opposites, would cancel. So that's kind of what they've done. They've canceled this right here. So 1x plus 1x is 2x. -2 plus 16 is -14. So now we're going to solve for x. X is equal to 7. Go back into one of the equations, solve, substitute in the 7, and solve for y to get the ordered pair. Now, always, 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 whoops, check to make sure that it works, okay? So if we have the x is 7 and this y is -3, right, is 7, I'm sorry, this is in place of right here. 7 plus the -9 equal to -2? Yes. Okay, if this is a 7 and this is a -3, 7 minus a -9 is like 7 plus 9 is 16. Yes, so it does work. All right, in the first several that we're going to do, it's already set up for us. We have something that will cancel, all right? So we really don't have to do step one because we already have a negative y and a positive y. So if we add these together, 2x plus 4x is 6x. -1 plus 1 is 0, that cancels. And 9 plus 21 is 30. And then we can solve for x. X is equal to 5. So let's go to one of the equations, the first equation, substitute in that x, and it's minus y is equal to 9. I did a really good job of canceling that, didn't I? So we have 10 minus y is equal to 9. We'll subtract 10 from both sides, and then we'll get y is equal to 1. So we'll have 5 comma 1. Now, we want to check to make sure that it works. Here's our checking. So 2 times 5, we have 10 minus 1 equal 9. Yes. And here, 4 times 5, we have 20 plus 1 equal to 21. Yes. So that step is really important so that if you don't get a true statement by checking, then there might have been a mathematical error. And I can tell you right now that the most errors that get made are with negative numbers. So you always want to be double checking it. All right. So let's try this next one. So number 2, negative 5x plus 5x is 0. So then I have 2 plus 1, so 3y is equal to 13 plus -1 is 12. So y is equal to 4. If y is equal to 4, I can go into my second equation. I can go into either, but I'm just going to pick the second equation. Subtract 4. So 5x is equal to negative 5, and x is equal to negative 1. I get the ordered pair, negative 1 comma 4. Okay. Then let's see if I want to check my work right here. So I'm substituting in the negative 1 right here. So negative 5 times negative 1 is 5. I'm substituting in a 4 here, plus 8. Is 5 plus 8 13? Yes. Here is the negative 1. Here is the 4. So negative 5 plus 4 equal to negative 1? Yes. Very important step. Okay, on the third one. Looking at this, nothing's going to cancel, right, if I add them. One thing I can do, and this is where we have to, part of the step 1, is what if I multiplied the second equation all by negative 1? So find something to multiply. So that means I'm going to multiply the 7x. So I'll get negative 7x. Then I'll get negative 4y and a positive 14. Okay? So I'm changing the sign of all of these, and I'm keeping the equality the same because I've distributed that evenly throughout and made sure that it's equivalent, just multiplied by the negative 1. Now I have the 3x plus the negative 7x, and I have a negative 4x. I have 4y minus y, so that's going to cancel. And then negative 6 plus 14 is going to be a positive 8. So I'll get an x is equal to negative 2. So I'll go to the top equation, 3 times negative 2 plus 4y is equal to a negative 6. So negative 6 plus 4y is equal to negative 6. If I add 6 to both sides, I'll get 4y is equal to 0, which means that y will be equal to 0. So I'm saying that the ordered pair here would be negative 2, 0. Well, let's check and make sure that that is the case. And I got to check both equations. I'm going to erase this, make it so that you can see it. All right. So 3 times, this is a negative 2. So we have negative 6 plus, and then this is times 0. 0 equals negative 6. It works for the first equation. All right. If x is negative 2 and y is 0, we'll have negative 14 plus 0 equal to negative 14, and it works for the second. So we know that this is, in fact, the actual solution, negative 2, 1. Okay, so sometimes we have to do a little bit more work, kind of like changing the sign or multiplying by negative 1. Sometimes we have to multiply by, say, 3, or sometimes we'll have to multiply both equations to get the least common multiple between the two numbers in order to get them to work. But it's easy to see that here we have this negative 6x, and if I multiply by 3, I'm going to take it one step further because they're saying we can subtract the equations, and I think that's just adding another step. So I want this to be the opposite sign. So I want to multiply by, let's say, let's multiply this by a negative 3. So negative 3 and negative 2x is a positive 6x. Negative 3 times negative 4 is a positive 12y. And negative 3 at times that would be equal to a negative 42. All right, I'm getting rid of this. So now I can go ahead and keep with the addition, right? So you can subtract, but then you're subtracting the first one, subtracting the second one, subtracting, and you have to work with double negatives. So I like getting the opposite signs. So here we would have our negative 6x and positive 6x that would cancel. Here we would get our 17y. I'm going to move it over here. And here we still get a negative 25. No, that's 25. What am I doing? I don't even know. All right. Negative 17 is what I meant to write. Okay, so now when we're dividing by the 17, we're going to get y is equal to -1, and then you follow along, and then you check your work. Okay, so let's continue solving, and let's figure it out what we need to do. So here, okay, we have a couple different options. I'm going to maybe work with the first one. I can multiply by a -2 so that my x's cancel, or I can multiply by a -3 so that my y's cancel. I'm just going to go ahead and pick the -2. All right, make sure that you're multiplying all three things. So -6x minus the 2y is equal to -22. Now I can add or combine these two equations. So this cancels. Then it's like 3 minus 2, so I get y is equal to, and then 24 plus -22 is 2. So going into my first equation, 3x plus 2, that's what I just got, is equal to 11. So subtract 2, 3x is equal to 9, and x is equal to 3. So I'm saying that my ordered pair is 3, 2. All right? I will only know that by checking it. So x is 3, y is 2. So 9 plus 2 equal to 11? Yes. X is 3, y is 2. So 18 plus 6 equal to 24? Yes, it is. Okay. I'm going to carry right along here. In number 5. So this is already a negative x, so if I multiply the second equation by 4, my x's would cancel. Remember that you're doing all three parts of that equation. So -4x, -8y, and 32. Now, this is gone, right? So 4x and -4x cancel. That's a -5, so make sure you're not making your work too messy. So when we add these together, we're going to get a negative 13y, and the 32 plus the -19 is equal to 13. All right. So that when I divide, y is equal to -1. If y is equal to -1, I have 4x minus 5 times -1 equal to -19. And so I'll subtract 5 from both sides, which then means I'm adding these, and I get, when I combine those, dividing by 4, x should be equal to -6. So my ordered pair here is -6, comma, -1. I need to erase so I can check my work. Okay. I have -6 and -1. So 4 and -6 is -24, minus 5 times -1 is -5. So that's like -24 plus 5, which is equal to -19. So it checks for that one. Then we have a -6 and a -1. So now we have the opposite of -6, which is 6. And then 2 times -1 is -2. The opposite of -2 is +2. So 6 plus 2 is 8. So make sure you're really careful with those integers. Final problem. This one's already solved for us. Very good. So go ahead and work this one out, right? This is, oh, they want us to do elimination though. I'm getting ready to do substitution, which, to be honest, in our next lesson, we're going to learn a little bit about, you solve these, since this is our third method of learning how to solve it. We've graphed them, we've substituted them, and now we're eliminating them. When you solve these, you usually always work with the easiest way. So let's go ahead and first put this into the correct shape. Let's maybe solve the top one by, well, we have let's just rearrange these. So let's do 5, I need to, 5y is equal to, let's do negative 5x plus 15, since that was negative and that was positive. Um, Again, I need to multiply, let's see, we could either, let's multiply this by negative 5, okay? So negative 5y is equal to positive 10x minus 15. All right, now I'm getting rid of this. So 5y minus 5y is 0, right? And that's going to be equal to, in this case, a negative 5x plus 10x is 5x, and 15 minus 15 is going to be 0, right? That cancels 2. So when we solve for x, we find that x is equal to 0. Now, if x is equal to 0, let's go to the second equation. So y is equal to 3. So 0, comma 3 would be my ordered pair. So let's double check. Let me erase here. Okay. So y is 3 and x is 0. So we'll have 15 is equal to 15 minus 0, right? That's true. 3, so this other one, it'd be 3 and then negative 2 times 0. So we're going to have 3 is equal to 0 plus 3, and it's true. So this is actually the correct solution. All right, so this is just a summary. So we want to use graphing, lesson 5.1, to estimate solutions. And it's always easiest sometimes to just graph from slope-intercept form, if you want to do that. Substitution is when one of the variables in the equation has a coefficient of 1 or negative 1. And as you noticed in that last example, I jumped ahead and wanted to use substitution because I'm always used to just solving it the easiest and quickest method. Elimination, when one of the pairs or like terms has the same or opposite coefficients, works pretty well too. And then we can use elimination to multiply first when we cannot initially just add or subtract. So lots of different choices here, and all for the same result, to find the place where the two lines intersect, or in the case that's like sometimes called the break-even point, where the two quantities are equal to each other.